class. Okay, class is recorded. Again, feel free to stop me at any time when you have questions, okay? So we're going to talk about section 3.1, 3.2. 3.1 is graph linear equations in two variables. What is linear equations in two variables? We call system of linear equations. So remember, linear equation represents a straight line, right? The two ends goes to infinities. It's just a linear function, linear equation, you know, linear equation, and also is a linear function. Sometimes the equation does not equal to the function, but for linear equations, yes, they represent a linear function. So basically, we have in two variables, we have a y, we have x, right? Y equals mx plus b, or ax plus by plus equals to c. Those represent linear equations. Let me type in the chat. So when we see linear equations, we should have something in mind like this. Y equals mx plus b. I'm typing it in the chat. Or ax plus by equals to c, right? Or even better one, y minus a number, usually we call y1, equals the slope m times x minus x1. So we have these three kinds of representations for linear equation or linear function. Depends on the, in what kind of context we call it equation or we call it function. So y equals mx plus b is called slope intercept form. Slope is m, right? 0, b is the y-intercept. So I think most of us are familiar with this representation. We have another one we call standard one, ax plus by equals c. Or slope intercept, slope point formula. So a point is x1, y1, slope is m, so we have y minus y1 equals m times x minus x1. So three different kinds of representations for linear equations. Okay, when we talk about functions, we change y to be f of x. But when we talk about equations, usually we use y. So how do we see those three? We can change one to other two. We can do the calculation, writing one in terms of other two. But how can we see those three as the same? We recognize by x comma y. We see in three equations, we all have x, which is just x raised by first power. We have y, right? This case, same thing. We have x, we have y. This case, same thing. We have x, we have y. So x comma y is a representative for any point on this line. Right? That's how we see these three, are equivalent. So this is called linear equations. When we put the linear equations together, maybe we'll have 2, we have 3. Usually for this class, we're going to solve for 2. Right? So 2 linear equations, which means, each equation represents a line, and 2 equations represent 2 lines. So we will say we have 3 kinds of possible solutions when we consider 2 linear equations together. So this one we call rectangular coordinate system, right? Or sometimes we call it Cartesian. Cartesian is by the mathematician's name Descartes. Cartesian coordinates, right? And points called ordered pairs. A point on the coordinate system has a fancy name, ordered pair. How to plot points and the origin. Let's see this. So this is, let me make a little bit smaller. So this is a Cartesian coordinates. All right. So we have x-axis, right? The blue color, the horizontal line, x-axis, so represents one dimension value. And we have this red color, y-axis, represents, with those two, we can record two-dimensional data, right? Each one can record one-dimension data. Think about a person's height and weight, right? Maybe this person is 3 years old. This boy is 3 years old, right? X value maybe 3 years old, and weight maybe 20 pounds or something as Y value, right? So a point can represent that. And with this system, we have quadrant 1. So the first quadrant, we see quadrant 1, right? X value is positive, Y value is positive. So any point in quadrant 1 has a positive X value, positive Y value. And mathematics like to go counterclockwise. So quadrant 2 is here. So going from quadrant 1 to quadrant 2, counterclockwise. So quadrant 2, we see X value is negative, Y value is positive. Going down, quadrant 3. Quadrant 3, X value negative, Y value negative. So both values are negative. Then quadrant 4, back to X value positive, but the Y value negative. So we have these 4 quadrants, all right? And the middle point, the point, the blue color, the blue line and the red line intersect is called the origin. Origin means the starting point. So it's 0 for x-axis, it's also 0 for y-axis. Right? On the left-hand side of 0, the origin, negative value represents x. On the right-hand side, on the blue color, blue line, positive. Right? And the origin was 0 for y. Down below, so 0, from 0 down, negative values. From 0 up, positive values. Right? So we use this coordinate system to record two-dimensional data, X value and Y value. So usually we use open parentheses. We use like this one. We use open parentheses, 0, 0, close parentheses to represent that. So let's see this example. In which quadrant X and Y value both negative? Quadrant 3, right? Where is X negative and the Y positive? Quadrant 2. Where is X always 0? Y-axis, right? So the points on Y-axis with the value, all the points has a value of X equals 0. So Y-axis, right, has another name, X equals 0 in two-dimensional world. Where is Y always equal to 0? X-axis, right? On X-axis, Y value is always 0. So X-axis has another name, Y equals 0. So this is in two-dimensional world. So the two intersects is the origin, 0, 0, 0 for X value, 0 for Y value. What does it mean on the coordinate system if we say Y is negative? Y is negative means the value, the point below X-axis, right? Which is quadrant 3 and quadrant 4. Right? All the points or all the ordered pairs below X-axis. Anyone has any questions about this coordinate system? Okay. So let's see in the 4 quadrant, we have 4 points, A, B, C, D. So A is in the first quadrant, X value positive 5, Y value positive 2. So that means A, so the X value is 5. You see 5 is from 0 count to the right, 5 units, right? Or we can drop a vertical line to x-axis. We see that's 5. Then from this point, we drop a horizontal line to y-axis. We see y value is 2. So the point A has x value 5, y value 2. Well, let's point B. We drop a vertical line to x-axis. That's -5. So x value is -5. We drop a horizontal line to y-axis. We see the value is 2. C. We drop a vertical line to x-axis. We see the value is -5. We drop a horizontal line to y-axis. We see the value is -2. D. X value 5, y value -2. A line is defined by 2 points. Right? With any 2 points, we can draw a line. So a line is defined by 2 points. And those 2 points are very special. This green color we call x-intercept, which y value is always 0, right? Y value is always 0. And this one, the red color we call y-intercept. Y-intercept, the x value is always 0. And with the linear equation, we call ax plus by equals c as a standard form. But if we have 4x minus 2y equals 6, that means a equals 4, b equals -2, and c equals to 6. So we call this a standard form, just a name, okay? And the solution of a linear equation, right, means all the points on the line, right, on the line, or any points on the line. So maybe, let's see this one, 1, -1, right? If we plug in 1 for x, -1 for y, we see 4 times 1 minus 2 times -1. 4 times 1 is 4, -2 times -1 is +2. 4 plus 2, that's 6. So indeed, equals 6. So 1 comma -1 is a solution. How do we graph a linear equation? Usually we need 2 points, but sometimes maybe we graph the point as a checkpoint, right? The graph of a linear equation is just, the set of all ordered pairs or the set of all points, but we won't be able to graph forever. So, so we usually just have part of the coordinates. The coordinate system, you can think it's just the 4 directions can go on forever, right? So this lines, goes on forever. Usually we use an arrow to represent goes on forever. Let's see how do we graph this one. 4x minus 2y equals 6. We said, we need 2 points to graph, right? So, and also we can use 2 special points, x-intercept and y-intercept. But normally we want to have a third point as a checkpoint, right? Third point as a checkpoint. So if all those 3 points lie on the same line, we know we did it right. But if it's not, we know somewhere we made a mistake. So usually we graph with 3 points, the third one as a checkpoint. So we could just choose so this is just, give you some thinking. Is 1, 3 a solution? You could try those, all right? But for the purpose of graphing it, we could just use x-intercept and y-intercept. This gives you some examples saying, okay, we could, if we want to check if it's 1 and 3 a solution, we just plug in x to be 1, y to be 3, right, to see if it equals 6. In this case, we see if x equals 1, y equals 3, we plug in we get 4 minus 6, we get -2, which is not equal to 6. So we know 1, 3 is not a solution, right, for this equation, or not a point on the graph. You could check those 2 points too. Well, and so we could do this. We can always assign x some value, then solve for y, solve for the corresponding y value, right? Because every point on this line has x value, has y value. You know, we can give x any value. We can give x any convenient value. So for this case, let's see, we let x be half. So we plug in half for x, then we try to solve for y. So 4 times half, that's 2. 2 minus 2y equals 6. So we subtract 2 on both sides. So -2y equals to 4. Then we divide by -2, so y equals to -2. So the corresponding y value is -2. So then we know half and -2 is a solution for this equation, or is a point on the graph. Similarly, we could let x be 0. So then 4 times 0 will be 0, have -2y equals 6. Then y equals to -3. What is this? X value is 0, y value -3. So this is a y-intercept, right? So we like to use this point to graph. Or you could let x equals 1 and do the same thing. Or better yet, let y be 0. Right? If y is 0, we have 4x minus 2 times 0 equals to 6. Right? Then 4x equals to 6. We divided by 4, so x equals to 6 divided by 4. Simplify, 3 halves. So what's this point? This point is x value is 3 halves, and the y value is 0. And this one is called x-intercept, because the y value is 0. Right? So we like this. We like to use those 2 special points. Ajeda, any questions?
Professor, can you hear me?
Yeah, I can hear you.
Sorry for raising my hand while you were speaking.
No, great.
So I had a question. In
Yeah.
this equation, they don't give you the slope as you would get in the y equals mx plus b version of the equation. So how would you do that on the line? Would you also be solving to get 2 points so that you can turn it into that equation and find the slope? Or do you just solve the equation to find as many points as you can and assume a line?
Okay, good question. For this 3, let me actually, so this is just a standard form. The other 2 forms, they're exactly the same. Let's use this one as example. We can turn 1 to the slope formula form. So in this case, I can do this. I can do -2y equals to -4x plus 6. Let's make sure you understand this one. You see, I just move 4x to the right-hand side. So the right-hand side positive becomes negative, right? Then I can divide everything by -2. So y equals to -4 divided by -2, that's 2x. And the 6 divided by -2, that's -3. Do you see y? Do you see slope intercept form? Now this 2 is m, right? So that's differently, yeah. And so we can just assign x to, for the purpose of graphing it, we only need to get 2 points, at the most 3 points. And we like to use x-intercept and the y-intercept. X-intercept, y-intercept means we assign x to be 0. Then we solve for corresponding y. X-intercept, we assign y to be 0. we solve for corresponding x. With these 2 points, we can graph. But if you want to be precise, you can use the point, right? You can let x be 1, use this point. Or you can let x be half, then use this point to graph it. So with the 3 points, if you graph those 3 points line on the same line, you know you did it right. Did I answer your question, Ajeda?
Yes, thank you very much.
You're welcome. Yeah. So x-intercept, make sure we try to remember those concepts. X-intercepts means y value is 0. Right? Y-intercept. X-intercept means all the points fall on x-axis. So that's why its y value is 0. Y-intercept means all the points fall on y-axis. So its x value is 0. Right? Let's go back to this. So make sure we know this. You see all the points, you see this y-intercept, right? Because on y-axis, what's the x value? 0. X-intercept for on x-axis, what is the y value? 0. So we like to use this one to graph, right? So find the x-intercept, y-intercept for this equation. Basically, we'll plug in, find the x-intercept, we plug in 0 for y, solve for x. For y-intercept, we plug in 0 for x, we solve for y. Okay. So when we talk about x-intercept, is a point, is an ordered pair. Okay. Y-intercept is an ordered pair or a point with x value, y value. Or x-intercept, y is 0. Y-intercept, x is 0. Right. Well, let's see this example. So we have 9x minus 4y equals negative 5. Right? So we want to find the x-intercept, which means we assign y to be 0. We assign y to be 0. Then we solve for x. So get negative 5 over 9, comma 0 as x-intercept. And we want to find the y-intercept, which means x value is 0. Then we solve for y. We solve for y equals 5 over 4. So 0, comma 5 over 4 is y-intercept. Negative 5 over 9, comma 0 is x-intercept. Now let's find the third point. So let x equals negative 1. Then we solve it. We solve for y. So y also equals negative 1. So we get a third point. Now with these 3 points, we can graph. Right? We just mark. So where is this one? On x-axis, right? Where is this one? On y-axis. But this is on the left-hand side of x-axis. The left-hand side of the origin. Above, so up, right? Up from the origin. This one is in the third quadrant. Anyone has any questions? Okay, let's see this one. We have slope intercept form. The slope is 2/3. The y-intercept is 0, comma, negative 5. Right? So we want to find the x, y-intercept. Well, x-intercept, we assign y to be 0. So that means 0 equals to 2/3 of x minus 5. Then we can move this -5 to the other side. It becomes positive. Then we multiply by the reciprocal of 2/3, which is 3/2. We multiply by this on both sides. Then 3 times 5, 15. 15 divided by 2. So that's the x value. Right? So the x-intercept is 15 over 2 comma 0. Well, y-intercept is obvious because this -5 give us the 0, because if x equals 0, 0 times 2/3 would be 0. 0 minus 5 would be -5. So that's why this is called slope-intercept form. Intercept means y-intercept. The x value is 0. So 0 comma -5. Usually we want to get the third point, right? We'll assign x to be 3 because we want these 3 cancel the 3 in the denominator. And then we get 3 comma -3 as the third point, as a checkpoint. So we can always assign x or y some value, but we can only assign to one of it, right? We cannot assign x value, y value at the same time because that may not make the equation equal to each other. So we assign one with a value, we solve for the other. We assign x some value, we solve for corresponding y. We can assign y for a value, then we solve for corresponding x. Horizontal lines or vertical lines, right? So this blue color is a vertical line, and it gets a name x equals to 3. So vertical lines means all the points on this line has x value the same. So y value can be anything, but the x value are the same. So x equals to 3. So that's how it gets its name. So all vertical lines has a name x equals to the number. And the horizontal lines has value of y equals to the y value. So this one is y equals to 5 because all the points on this line has a value of 5. Has y value 5. And the x value can be any number. So those two special lines, one is a vertical line, one is horizontal line. Horizontal line is a function we'll talk about later. Vertical line is not a function. So find the equation of the vertical line goes through this point. Well, this point, vertical line, we know the x value, right? Is x equals to the x value. Well, the x value is 9. So that means the vertical line is x equals to 9. Well, horizontal line goes through this point. Horizontal line is y value. Y equals to the y value, which means y equals to -7. So from any point will give us two lines. One vertical line, right, equals to the x value. One horizontal line equals to the y value. Any questions? All right. Slope of a line. I already mentioned slope, right? Y equals mx plus b. M represents a slope. But what is m? M, people like to see equals rise over run, right? How much from one point to another point? How much does this point have to go up or go down? Run, so rise means vertical distance. Run means horizontal distance. So let's see from this graph. We have 2 points. We have this point, we have this point. So from this point to this point, how much did it has to rise up? And how many units did he has to run to the left or right? Right means up and down. Run means left or right. So also we could use this notation. So changing in y or y2 minus y1. If we name those 2 points, x1, y1, x2, y2, right? y2 minus y1 divided by x2 minus x1, that's slope. Let's see this one. Let's see this example. So this one we have linear equation. We have y equals 2x minus 5. So we call this slope-intercept form. The slope is the number before x. Slope is the number before x, so which is 2. So m equals 2 here. And the y-intercept is 0, comma, negative 5. Okay, the first value is always 0. X value is always 0. Y-intercept, x value is always 0. 0, negative 5 is the y-intercept. What about in this case? What's the slope of this one? What's the number before x? It seems like no number. No number means 1 by default or by convention. X means 1x, means x divided by 1, means x raised by 1. We just don't bother to write those ones, right? So just by convention. So this slope equals to 1. Let's see this one. What's the slope of y equals 5? Horizontal line. Well, m equals 0. Why? Because 0 killed the x term. 0 times x becomes 0. So the slope is 0 for horizontal lines. What about for vertical lines? X equals 2. Y is absent, so there's no slope. Okay. This one has no slope. Or we see slope is undefined. Or slope does not exist. All right. So vertical lines, right? Especially horizontal lines has slope. Slope equals 0. But vertical lines has no slope. So if a line goes from the third quadrant, from the first quadrant like this, the third quadrant cross third quadrant, or second quadrant or fourth quadrant, doesn't matter. But the 2 arrows is on the third quadrant and the first quadrant, it has a positive slope. If the arrow shows in the second quadrant and fourth quadrant, it has a negative slope, negative number. Horizontal line slope is 0. Vertical lines the slope is undefined. So this one, the first one we call increase. But from this point to this point to this point to this, from left to right, we see increase. And this one, this kind of graph we call decrease. Decrease. But from this point, we look at it from left to right, decrease. And horizontal lines is constant, doesn't change, doesn't increase, doesn't decrease. A vertical line, we just don't, it's just an equation, right? It has no slope. Okay, formula for slope of a line. Let's see, we have these 2 points. We call the first point x1, comma y1. The second point x2, comma y2. Right. The slope equals y2 minus y1. Rise over right, y2 minus y1 divided by x2 minus x1. Or changing in y divided by changing in x. Let me see if I can do this. Changing in y. changing x. So from first point to second point, how much did it change in y value? How much change in x value? So let's see these two examples. So the first point we have 2, 3. The second point was 7, 6. So x minus x1, we see x2 minus x1. x2 is 7, x1 is 2. So 7 minus 2, that's 5. That's run. So from point 1 to point 2, it has to run 5 units. What about rise? Rise is y2 minus y1. y2 is 6, y1 is 3. So y2 minus y1 is 6 minus 3, which is 3. So it has to rise up 3 units, has to run to the right 5 units. So rise up is positive, run to the right is positive. If we run down, that would be negative. If we rise down, if we go downward, that would be negative. If we will run to the left, that would be negative. So in this case, what's the slope? Slope is y2 minus y1, which is 3, divided by x2 minus x1, which is 5. So slope is 3 over 5. Any questions? Six minus 3, which is 3. 7 minus 2, which is 5. So that's 3 over 5. If you're given a point and given a slope, we would use a slope point formula, or we can graph it like this. Okay. So let's say point 1 comma negative 1. So we have this point 1 comma negative 1. And then the slope is 3 over 4. 3 over 4 means we have to rise 3 units. 4 means in the denominator means we have to go to the right hand side 4 units. So from this point, 3 units up, 1, 2, 3, we end up at 2. Then we have to run to the right 4 units. So 1, 2, 3, 4. That means I could have a point here. I could have a point here. So see, 1 plus 4, right? Because rise up 4 units. Hold on. Run 4 units, right? Because the denominator is 4. We have to run to the right 4 units. So 1 plus 4, 5. Rise up 3 units, so negative 1. Rise up 3 units plus 3, which is 2. So 5 comma 2, right? We still have a point here, 5 comma 2. If the fraction is negative, would it run down? Yeah. Let's see a negative. Do I have a negative? Right. Let's change this a little bit. Let's see now. This is a negative 3. Negative 3/4. So if it's a negative slope, we can choose. So from this point, we can choose one direction. We could just choose y value to go down 3 units. Okay, let me do this. Let me do this first. If the slope is negative, let me write here. If m equals to negative 3 over 4, so what can we do? We could do either, I'm going to copy this one. Oops. Okay, if we have this, I can think one way the numerator is negative, or the denominator is negative. What does this mean? But these two means a different thing. But I'm gonna go back to see this one first. So this means move up 3 units, right? 4 means, positive 4 means move to the right 4 units. So when both positive, right? The numerator is positive, the denominator is positive. Let me. Three positive means move up 3 units, rise. Right? Rise 3 units, or let me use rise. Rise 3 units up. Rise up, let's see, rise up 3 units. Okay, run to the right. Let's use rise and run. Run to the right 4 units. Now, when it's negative, so that's why we do 1. So 1 is x value, right? X value corresponding to the denominator, 1 plus 4. And then -1, well, -1 is y value. Y value is corresponding to the numerator, because the numerator is y2 minus y1 plus 3. Right. And here, when it's negative, what does this mean? This one means, I'm going to change this. So this one means negative means run down 3 units, not up. Right? Run down 3 units because it's a -3. But the 4 is still positive, still run to the right 4 units. What about this one? Or it could be 4 m equals to this. And what is this? This means rise up 3 units, but run to the left, because it's a -4. Run to the left 4 units, all right? We get different points. If we do this way, we will get different points. Right? Let's just see this. We get different points. So this, the point we will get is 1, still plus 4, and -1 minus 3. All right? Even different points, because there are infinitely many points on the same line, right? We just get a different point, but the point still will be on the line. And for this one, what point we will get? We will get 1 minus 4, because we run to the left. 3 plus, no, hold on, -1. -1 plus 3, all right? Okay, any questions? So when the negative sign in front of a fraction, we have choice. We can put the negative sign with the numerator, or we can put the negative sign with the denominator. slope-intercept form of an equation of a line, right? Y equals mx plus b. M is the slope. Y-intercept is 0, comma b. If we have m equals 2, y-intercept is 0, comma negative 2. So we can write, that means b equals negative 2, m equals 2. So y equals to 2 slope x plus negative 2, or plus negative, which means minus, right? So the equation is y equals to 2x minus 2. Well, let's see this one. We have y equals to negative half x minus 5. The number before x is slope, right? Negative half is slope. And the b equals to negative 5, so the y-intercept is 0, comma, negative 5. Let's see this example. This example was given a standard form. And the question wants us to write this one as slope-intercept form. So from standard form, we're going to write as a slope-intercept form. So basically from ax plus by equals to c to y equals to mx plus b. So how do we do that? That means to solve for y, actually. The steps means to solve for y. So we need to solve for y. So first we move 3x to the right-hand side, becomes negative. Then we divide by negative 2 on both sides, right? So negative 3 divided by negative 2, that is 3 over 2. Then 6 divided by negative 2, this is negative 3. So y is solved. We see the number before x is a slope, which is 3 over 2. And b is a constant term, right? So the y-intercept is 0, comma, negative 3. So it has to be y. It has to be, y means 1y, right? Any questions? Well, let's see this one. We have 4x minus 12y equals 36. Right. We want to write as slope-intercept form. What do we do? First, we move 4x to the other hand side, to the right-hand side, becomes negative. So the equation becomes negative 12y. Do not forget about this negative sign, okay? So the left-hand side, we have two terms. We have 4x positive, we have negative 12y negative. The right-hand side, we have one term, positive 36. So first, we move positive 4x to the right-hand side, becomes negative. Then we divide by negative 12 for all three terms. So negative 4 divided by negative 12, that's 1/3. 36 divided by negative 12, that's negative 3. Right, so its slope is 1/3. Y-intercept is 0, comma, negative 3. If we talk about two lines, right, two lines can be parallel, can be perpendicular. Parallel means two lines will never meet. Okay, the distance from any point you draw a distance to the other line, they're the same. They're parallel. They will never intersect each other. Perpendicular means the two lines form 90 degrees. The two lines form a right triangle. A right angle. Two lines form 90 degrees, called perpendicular. So parallel lines means their slopes are the same. All right. Slope of the first line equals to the slope of the second line. So parallel lines have the same slope. Perpendicular lines have this relationship. If we multiply the two slopes, we will get -1. Or the slope of one is the negative, It's the opposite, not negative. We can say negative. It's the opposite inverse of the other. Or just, the product of two slopes equals -1. If anyone has any questions. Reciprocal. Yeah, you could call reciprocal. Yeah. Or multiplicative inverse. Yeah, we'll see some examples. Let's see these two. We have y equal to 2x minus 1, y equal to 2x plus 3, and those two lines are parallel because the slopes are the same. Well, let's see these two lines. Y equals to 2x minus 1, y equals to -half x plus 2. Well, what's 2 times -half? 2 times -half is -1. So those two lines are perpendicular. Let's see some lines, two lines are perpendicular. If one has a slope of 2/3, the other one has the opposite. Opposite means the signs are opposite. So this one is positive. The perpendicular one slope has to be negative. If this is 2/3, the other one is 3/2. It's a reciprocal if we switch the numerator and denominator, because 2/3 times 4, 2/3 times -3/2 equals to -1. Okay. If one has a slope of -3/4, that the other one has to be positive 4/3. It's -3/4 times 4/3 equals to -1. If one is 11/3, the other one has to be -13/11. We'll just flip the numerator and denominator. What is the reciprocal of a fraction? Let's just flip the numerator and denominator. So 11/13 times -13/11 equals to -1. Let's see word problems. So this problem is saying Bruce drives his car for his job. The equation R equals to 0.575 m plus 42 models the relation between the amount in dollars, R, so R is a quantity in dollars, that he is reimbursed, and the number of miles, M, he drives in one day. Okay, so this equation represents Bruce's reimbursement. So this R is in dollars, and this M is how many miles he drives in one day. Okay. For each mile he drives, he gets 0.575. Then this whole thing plus 42. Do you see this is a slope-intercept form? You could think R as y, M as x. What's the number before x? The slope. This is the slope, right? 0.575 is the slope. And what's the y-intercept? 0, 42. So what do we have to do with this one? So this is a linear model, right? Linear. So this is a linear equation, linear model. First, find the amount Bruce is reimbursed on a day when he drives 0 miles. When he drives 0 miles means M equals 0, right? M equals 0. If this R looks strange, M looks strange for you, you could change R to be Y. You could think this M to be X, all right? You could think this is a Y equals 0.575 X plus 42. You could think that way. So if he drives 0 miles, so that means X or M equals 0. So what's that? When that's 0, that's 42 miles, right? $42. So 0.575 times 0 plus 42, 42. So he'll be reimbursed with $42. B, find the amount Bruce is reimbursed on a day when he drives 220 miles. That means M equals 220. So we just use 0.575 times 220 plus 42. Well, that's 168.5. So he'll be reimbursed with $168.50 if he drives 220 miles. C, interpret the slope and R or y-intercept of the equation. What do they represent within the context of the problem? Right? What's the slope? The slope is 0.575. The slope equals 0.575. And what is the R-intercept or y-intercept? That means he drives no miles, right? So what does this mean? This means for each mile he drives, he will be reimbursed for this much money. 0.575 dollars. Okay, that's the meaning of it. So for each mile he drives, he will be reimbursed for 0.575 dollars, because M represents how many miles he drives in one day. What about y-intercept? Well, R-intercept in this case, because we'll call the equation on the other side R, could call R-intercept or y-intercept, means when he drives, he will be reimbursed with $42 if he doesn't drive that day. Okay, but he drives no miles, M equals 0. He doesn't drive that day. Right. Any questions? Okay, let's see next example. Margie is planning a dinner banquet. The equation C equals 750 plus 40G. Again, if that bothers you, you change it to Y or X, all right? But what's the variable? The variable is G and the C, right? So even this read this way, we recognize that should be written as 42G plus 750, right? What's the slope? The slope is 42. What's the constant? What's y-intercept or c-intercept? C-intercept is 0,750. So this is y equals to 42x plus 750. So this models the relation between the cost in dollars. So C represents the cost in dollars of the banquet and the number of guests. So G represents the number of guests. So A, find the cost if the number of guests is 50. That means G equals 50, right? We just plug in G for 50. So that means C equals 750 plus 42 times 50. Well, that's $2,850. So she has to spend this much money if she has 50 guests. What about if she has 100 guests? That means G equals 100. Well, she needs to spend $4,950. C, interpret the slope and intercept of the equation. What do they represent within the context of the problem? So you could think that's y equals 42x plus 750, right? So slope is 42. What does it represent? Slope is 42. It represents each guest would cost her $42, right? For each guest, it costs Margie $42. That's what the slope represents, right? Because 42 times how many guests she has. For each one guest will cost her $42. What about c-intercept? Well, c-intercept is 0, 750, which means it costs Margie $750. $750 if she has no guest. Even she has no guest. So the overhead of this banquet is $750. The overhead of this banquet is $750. Then each guest is going to cost her $42. Anyone has any questions? Okay, so that's it. So basically today we talk about the linear equations, right? Each linear equation is a linear model and can be represented with 3 different kinds of representations. And also sometimes it's called a linear equation in 2 variables because we see x, we see y. Okay, maybe I'll write it over here. It has 3 representations. There could be y equals to mx plus b, or it could be, that's called a y-intercept form, it could be ax plus by equals to c, or it could be y minus y1 equals to m equals to m times x minus x1, right? So this one is called slope-intercept form. This one is called a standard form. This one is called a slope point form. Right. So we see a slope, we see a point. x1, y1 is a given point. Okay. Anyone has any questions? Eleven, 10. No? Okay. If you have no questions, go ahead, start doing your homework. If you do have questions, I'm here to discuss with you. Okay, bye. Thank you. Have a good weekend. Have a good weekend. Let me stop recording this.